Thank you very much for coming. I am really thrilled to be here today. I'm very used to being the oddball in conferences, particularly technology conferences, because I'm so incredibly low tech. But I've never felt so at home than in this one. I feel like I share actually so many things in common with you, even though I don't really use the computer all that much. And for that reason, I'm thrilled to be here today. And I want to thank Jer and Dave for inviting me. A lot of you in the audience are artists who I looked at your work for many years, so I'm really thrilled. I feel like you're my peers and my heroes and everything. So thank you. OK, so I'm going to talk to you about my work today, but I'm actually going to focus a little bit more about the process itself, because I know that you all like looking at numbers. I know you all like looking at data. And I was thinking about framing the conversation so that I share the process with you, and maybe you can take something away from this talk as well. So I am a sculptor, and I translate information into three-dimensional woven forms using basket weaving as my main method of translation. And because I'm so deeply entrenched in the physical, tactile world, I think a lot about how we convey information nowadays. And the majority, or the most common way that we convey information nowadays, or that we interact with information, is through the digital realm. So as a tactile thinker who has to touch things in order to understand things, I think a lot about what would our understanding of information be if we could touch it, if we could hear it, if we could actually walk around it. And how do the mediums that we choose to translate information with, and the larger patterns that they create, how do those mediums frame and shape the way we understand it? And are we perhaps losing a kind of spatial, tactile sensitivity to information by relying so heavily on the computer as our medium of translation? So I'm going to focus today on my process. I want to start with you first with an experience that I had in 2002. I bring my work to a lot of different audiences, including science audiences, because I find that some of the questions that I get about the work are much more interesting when it leaves the art world. And I bring it to a lot of science teachers' conferences. They're very curious folks. And this is a science teacher conference that I went to in 2002 at the McDonnell Observatory in Texas. This was all astronomy teachers. And at night, we had a chance to look through one of the telescopes. And you know, the usual suspects, we looked at Mars, we looked at Venus, we looked at Saturn, and we looked at a lot of other objects. But as the night progressed, they started to turn the telescope towards objects that I hadn't known, or that I had never seen before. And one of them was the Helix Nebula. So people were looking through the eyepiece, and they were oohing and eyeing. And finally, it was my turn, and this is what I saw. Nothing. And the guy next to me realized that something wasn't clicking, and he said, no, 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 take another look, and this time don't look directly into the darkness. Look past it. In other words, use your peripheral vision to look through the eyepiece. And after a few seconds, this is what I saw. And as soon as I focused on it, it was gone again. But the reason this experience has stayed in my mind is particularly when it comes to translating weather data, which is my primary focus. It's not always what you see in front of you that's the most important. It's actually what's going on around you. It's all the stuff that's going on peripherally around you that becomes incredibly important in translating and understanding data. So peripheral vision and an acceptance of blindness is something that I value very much in my translation process. So all of my work is driven by numbers. Every single bead, every single colorful strand, every single piece of reed that you see in the sculpture is actually driven by numbers that I translate. And so together, these numbers not only create the form, but they also reveal behavioral relationships that you would not see through a two-dimensional graph. Now, in my studio is this piece of paper that I wrote a few years ago in this sort of fit of over-caffeine, I suppose. And I wrote these sentences down, and I stuck it on my pile of wood. And it's stayed there ever since. And I'm certainly not the type that goes to self-help books in the book section. But it's been a kind of self-help for me that whenever I'm stuck with data, or whenever I feel my blinders coming up with data, I go to this piece of paper. And let me just read to you what it says. Don't overthink what you do. Remember the logic of dreams, the way reason warps itself into a strangely convincing logic within a dream. The miniature has greatness. This is a reference to Gaston Bachelard's The Poetics of Space. Don't make it didactic. Make it poetic. Allow it to find its own contradictions and build its own sense of logic. Trust the sculpture. Play as an elastic form of logic. And what I've found over time is that there are partners that I have in the studio that I use a lot when I think about information. And those 3 partners are play, slowness, and contradictions, or it doesn't always have to make complete sense. And I'll talk about play and slowness in my talk, but I want to just briefly talk about contradictions. When I started this work, I was very much interested in creating 3-dimensional graphs, and I'm no longer interested in that. So at the beginning, the work was very much about using sculpture to understand science better. So sculpture was in the service of data. Now that equation has changed. Now it's much more that data is actually helping me understand sculpture better. And as a result, the work is becoming more open-ended. There are a lot more contradictions in there. There are a lot more idiosyncrasies in there, and I understand the work less. But it's actually been a lesson in learning to accept contradictions and allowing them to exist in a piece, and I find the work to be much more interesting to myself. So, play. The first thing that I think a lot about in my studio is play. When people look at my work and they don't know it's about data, the first thing they think about is, oh, it looks like construction toys. It looks like this weird, playful, crazy land of toys. And a lot of people erroneously think it's for children, and the work is very much not for children. Children don't need this work. They get it much better than we do. This work is actually very much for you guys. It's for adults, and it's for myself. And what happens is that when a person looks at this work, they look at all these colorful beads and cars and everything, and it reminds them of toys. And when they look longer at it, they realize that all these little beads and toys and even the cars there actually refer to a specific data point. So there's actually a numerical logic that holds this cacophony of colors together. And what I'm trying to do is lure the viewer into the information without immediately framing it as a science, without immediately framing it towards a specific discipline, whether that be science, history, or economics, or whatever it is. I also spend an enormous amount of time in toy stores. And I think of toy stores as my hunting grounds. And I buy a lot of toys. I don't have kids, but you would never think that when you go to my apartment. And the reason I do is because these toys are enormously important to me, because they are like scaffoldings of thought. I think about these toys and I play with these toys when I translate data. So even though this looks like just a usual Tinker Toy sculpture, what if this was a calendar? What if you could use this kind of platform to translate a calendar, for example, on it? Or here, I've always been fascinated by Jacob's ladder. There's got to be something. I haven't figured out what to do with it yet. But they help me really think about how physical structures can be used to find playful ways of translating information. Now, I want to talk briefly about play. When I think about play, there's sort of 2 different things that two different definitions of play that I think about. The first one is the way play expresses itself on a soccer field. In a soccer field, you have the physical parameter of the field, and you have the rules, and those guide the players in bringing the ball into the net. And if you break the rules, what's the English word? You do a foul. It's not quite how you say it, but you know what I mean. And I use those same kind of parameters in my work. It's by not changing the information for any aesthetic purpose and still telling the scientific story. Those are my parameters that I use. And within those parameters, within those rules, I try to find a lot of different ways of telling that story. So I cannot change the data for any aesthetic purpose. The other way that I think about play is exemplified by one of my favorite illustrators, Winsor McCay's Little Nemo in Slumberland. And if those of you who may not be familiar with this cartoon strip, it was from the early 20th century, and Little Nemo is this little boy who basically the whole comic strip is about him having nightmares. And what's interesting to me is that in that comic strip, it always starts with him on the bed, and then there's some sort of physical object that brings him into that world of sleeping, or the dream world. And that physical object always changes. So oftentimes it's the bed. So the bed becomes a boat, it becomes a ship, it grows stilts, it just changes in all sorts of ways. But what's interesting is that Nemo never loses the reality. For him, the reality and Slumberland all become one. And what I'm trying to do with my work is use the object in that way. So when you're looking at an object like this, you know there's the logic of numbers, but there's also that craziness of toys, that craziness of play. So you never quite know, are you in the real world or are you in the fantasy world? And I love that interplay of not quite knowing where you are. So all of my work begins with me extracting information from a specific environment using very low-tech gathering devices. So that means going to the local hardware store and going through every single aisle and finding something that can measure things. Sometimes I build my own data collecting devices. So I go to a specific place, I extract information, I go to the internet, I compare my findings to local weather stations, satellites, offshore buoys, and I compile all of this on these clipboards. And each of these clipboards that you see on the slide is a sculpture. So I'm starting with a whole bunch of papers, piles and piles of numbers. And from these piles of numbers, I usually start my translation process with only 2 or 3 variables. The translation process then goes from numbers into sculpture directly, or sometimes it goes from numbers into a musical score and then into a sculpture, which is the case with this guy here that I brought with me. So this piece here is Hurricane Noel. Hurricane Noel was a storm system that came up the eastern seaboard, and it's a very typical fall hurricane, and I happened to be on the beach recording this hurricane, and being on the beach and trying to record weather at 60-mile-an-hour wind is an unbelievable experience, and in fact, I don't have the data because the wind ripped away my equipment, so I don't actually have the information. So what I had to do is rely on 2 weather stations instead, a weather station in Quebec and a weather station on Cape Cod and an offshore buoy, and from these, I gathered information. And with that, I constructed a score, a musical score. So I gathered wind, temperature, barometric pressure, assigned each of these 3 values keys on a piano keyboard, and then over time, these 3 values actually build the score. Now, I am not a composer. I don't play music. I don't know how to read music, and on top of everything, I'm tone deaf. So to go into musical notation was sort of kind of the dumbest thing you could do. But when I build these scores, I don't build them like a composer. I build them like a sculptor. Because for me, these scores have to not only function, they have to function in the sense that a musician can play them, but they also have to function sculpturally. So I don't think about what it sounds like. I don't even care what it sounds like when I start this one. So this musical score then becomes a direct translation to this. So this is actually the score. And so what this is a data visualization of the storm, so you can actually read the data of Hurricane Noel. You can figure out what the temperature was at 8 o'clock in the evening and so forth. But it also integrates that musical visual structure of the score so that a musician can actually play off the sculpture. So what you're going to hear now is an excerpt of the Axis Ensemble playing that score. And what I'm interested here is, well, first of all, what you're going to hear is not an expression of weather. What you're hearing are the weather variables interacting with one another. And what I'm interested here is how the dissonance and the harmony together build up this nuance of information. So one of the reasons I go into musical notation is because we are much better in hearing differences in sound than we are in actually being able to see differences in color or in vision. So we're much more sensitive through our hearing. And so I'm interested in what kind of nuances can come out through the information that are much more difficult to do sculpturally. So let's listen to that little excerpt. What interests me about this work is that when you take this sculpture and you place it in a science museum, it's a data visualization. You place it in the Walker, for example, it becomes an aesthetic object. You place it in a music hall, it now becomes a functional musical score. So it really forces the viewer to think about what kind of visual vocabulary this is. Is this scientific? Is this artistic? Is it musical? What really is it? And I think one of the reasons why I gravitated towards weaving, particularly basket weaving, is because it is a kind of method that makes me very aware of the hand. So I've been using basket weaving since the very beginning of my data translation, which is about 12 years ago. And baskets are really fascinating objects. They are very, very old. They are as old as human civilizations. And one thing that's really interesting is that in those thousands of years, the methods or the techniques of basket weaving have not changed. So twining, coiling, and plaiting are very basic basket weaving techniques that a napkin basket in 500 BC would be very similar to the napkin basket you would see here in the cafeteria in 2012. They haven't changed. What has changed, of course, are the materials and the functions. But the techniques haven't. And I gravitated towards the basket not because of any kind of anthropological object, even though I think they're incredibly beautiful. I gravitated towards it because it's a very simple three-dimensional grid that I can manipulate through numbers. It's a grid that is held together by tension. The other thing, though, that basket weaving is basket weaving is a very slow art. You cannot make a basket very fast. There's a slowness embedded in the process. And even though it's frustrating as hell when I have a deadline to have to struggle and weave a sculpture together, it's actually also that slowness that helps me slow down and actually listen to the information and actually think about the information and linger in the question as opposed to immediately bring the data translation towards a specific answer. That same kind of slowness is also something that I discovered in weather observation. Weather observation is something that reveals itself only over time. And when you go into an environment, you plop down your weather instruments, and you extract information from it, there's no way that you're really going to understand weather in that environment. Because weather is an amalgam of systems that interacts with another amalgam of systems in an environment. So to observe weather is to observe the environment. And environments have a habit of revealing their patterns slowly over time. So it takes me months and months and months to really understand or begin to understand an environment and how it interacts with weather. So slowness, as frustrating as it is to be dealing with this in this fast world, is something that has been very instrumental in helping me understand, or I think understand, information. So how did this all start? It started all out because I wanted to understand astronomy better. And the conundrum of astronomy is that you have the deepest of space and the deepest of time, and yet you cannot go out and touch a star. You cannot go jump onto a little spaceship and tour the solar system. So physical space in the context of astronomy always remains a little bit abstract. And as a kinesthetic learner who's got to touch these things in order to understand them, I had to bust through that two-dimensional plane of the computer screen in order to understand the science behind it. When we learn about astronomy in a typical astronomy class, you oftentimes come across these kind of diagrams. Here you have the sun, the moon, and the earth, and they're zipping around one another, and you're this bird flying out there somewhere in the solar system watching this interaction. But that's not how we experience it on Earth. On Earth, we experience this interaction as these bands in the night sky. So in that sense, this kind of diagram, or this kind of representation, is much more embedded in the physical experience of these cycles, the solar and the lunar cycle. So in my astronomy class, which is about 12 years ago, I decided that I had to somehow figure out a way of making this more dimensional. So for my final paper, I took the Hertzsprung-Russell diagram, which if there are any astronomers in here, you know this is sort of an incredible diagram. It only takes two values, surface temperature and luminosity of any star, and you can map the evolutionary star or the state of any star in the universe. So I took a very straightforward way. I took this diagram, I made a drawing out of it, and then wove the sculpture and handed this in as my final paper. And so basically, what you can read of this is from temperature, I guess from left to right is the temperature gets higher, and then the diameter of the piece is the actual luminosity. And the thing is, it only takes one nut out there to believe in your idea, and that's exactly what that professor was. He thought this was fantastic and invited me to science conferences to share my ideas with science teachers, and if it wasn't for him and being open to this idea of this being a final paper, I don't think I would ever be here talking to you today. So thank you for believing in crazy ideas, I guess. But it was actually these kind of very dry-looking numbers that were really the breakthrough for me in terms of basket weaving. And these are, again, looking at solar and lunar cycles and how they're represented to us. And I came across a lot of these very dry-looking sheets of paper with numbers. But what if these numbers were Lego pieces? What if they could actually jump off the page and I could build something with them? And that's, again, where the basket came in, but in a little bit more, not such a didactic way, in a bit more of a profound way, I think. So the basket is a very simple three-dimensional grid. It has vertical and horizontal elements. And let's say I wanted to translate this kind of information. I'm translating moon and sun data of McMurdo, Antarctica. So when the sun rises and when the sun rises, and when the moon and the sun rise and set. I begin by assigning values to the vertical elements. So each pair of these vertical spokes, as they call them in basket weaving, is assigned an hour. So if I were to go around once, I have 24 hours. Then I weave moon data, which is the flat read, and the sun data, which is the round read. And you see that the very beginning, the moon is up 24 hours, and the sun only comes in about in mid-August. And what happens is that over time, the tension of this basket grid starts changing, and it starts warping this grid. The other reason why I use basket weaving material, reed, is because it's a natural material that has a lot of tension, which means I do not control the form. It's the numbers that are controlling the form. If I exert too much control on the material, it breaks. So that's why I stick with this material. So let's look what happens when I translate information over several months worth of data. So this is taking the same kind of 24-hour base, but now I'm looking at moon data, twilight data, and sun data, again, still from McMurdo, Antarctica. And basically what I'm looking at is the first slither of sunlight in mid-June to the first day of 24-hour sunlight in October. And what you see are these warps that are starting to come into the piece. These warps are created by the numbers. That's not me imposing these warps onto it. So once I have a form, once I'm finished weaving, I not only have a physical form, but I now also have a kind of three-dimensional calendar on which I can plot more stuff on. And so when you get closer, you realize there's a lot more information on there. So there's the solar azimuth, solar hours, moon phases, low tide, high tide readings, and so forth. I turned to weather probably about 6 years ago, and I did a whole series on sculptures that focused on data that I collected from a specific place on Cape Cod. So this is one example of that. This piece here is using, again, that same 24-hour cycle that you saw in the previous pieces, and I'm looking at air and water temperatures during a particular warm period, December, January 2007, 2008, and translating that. A lot of times, the sculptures are actually built by using different data sources to build different parts of the sculpture. So the outer body is built from data from weather stations that were nearby of where I was gathering the information. The inner part is historical data, and the data that I collected from the beach are these sort of peripheral elements that are hanging out on the side. And again, if you get closer in, you realize that here's that same 24-hour band. That 24-hour band has now also been given a range of temperature from 20 to 75 degrees Fahrenheit. And then you can read off the air temperature, water temperature, high tide, and moon phases of these things. Here's a tidal calendar of Boston. So the form itself, the woven part, is the solar and lunar calendar of 1 year based in Boston. Those blue sticks are the tidal readings of every day. The black dots are the moon phases. So this is the new moon. And then the sort of the spiky part in the middle is the solar azimuth for an entire year. This is a series of pieces I did on buoys that were located all over the Gulf of Maine. The Gulf of Maine is our New England waters, is our ocean, I guess the Atlantic Ocean in the New England area. And I was interested in trying to understand why right whales hang out in certain parts of the Gulf of Maine in certain times of the year. And I looked at all the buoys that are located out there and used buoy information to translate the information to try to understand why they were there. So I did a whole series of buoy things. This is a piece I did on temporal warmth, which means I translated air, water, and sea temperatures of a specific place on Cape Cod and then translated that into a woven form. Again, these warps that you see is the information actually changing and warping it. And so I did a whole bunch of these pieces. But one thing that happened about, I guess maybe 3 years ago now, or 2 years ago, is that I started to get into musical notation. And the beauty of naivete is that you don't realize how naive you are until you're really neck deep into something and you realize, holy moly, and you're in it. And that's certainly been the case with music. I've never been so humbled by anything than with music. But the reason I got into this is because to me, musical notation is sort of the perfect data translation language. A composer can take a series of notes and make these notes sound happy, fast, erratic, emotional, sad, just by changing the notation around the note, but actually not changing the note itself. So it's a language that allows you to translate information, give more nuance to the reading of the information without actually fudging the information. So I started to use musical notation as a way of translating information that I wanted to bring in a little bit more of a nuanced reading, because I was starting to become much more interested in not so much how instruments record weather, but how we as humans understand weather. Instruments never get the flu, they never get moody, and they never fall in love. But we do, and it changes the way we understand weather. If I were to ask you all, what was the weather like on September 11th, 2001, most of you would remember. But hardly any of you probably would remember what the weather was like on September 10th. So weather is really ingrained into, and our emotional state is really ingrained into how we remember weather. So this score here is actually a score of the passing of my father-in-law. So it tracks the weather data from the day he died to his funeral. And I built the score with very dry-looking information, cloud cover, temperature, humidity, barometric pressure that I got from my weather station. So you have this very objective, every 6-hour kind of weather reading. But embedded in this is the tempo reading, which are these black lines that you see in there. And when you go through a traumatic experience like the death of a loved one, time never feels like a metronome. Time expands, contracts, and you're all over the place, but you're certainly never a metronome. And so the tempo was a way of bringing in that sense of time and how fragmented everything felt. So the information is translated through that sort of very erratic measurement of time. And then this is the sculpture that I built, which is, again, functions in the same way as this one does. You can read the data, the weather data off the sculpture, but it also integrates the musical notation, so you can play that score off the piece. Here's another piece that talks about the same kind of thing, that sort of emotional reading of weather data, stormy weather internal storm. This is looking at a very, very big storm system that went through the Boston area and which coincided with a very emotional visit by my parents. And the stormy weather brought out the internal storms, so there was a lot of friction going on there. And so this is the score that I first wrote, and then the sculpture that was translated. A lot of times I include a kind of legend with pieces so that people can decode what all these different things are on the sculpture. And then you will now hear Elaine Rombola playing part of that score. She's a pianist. So the reason I work with musicians is not because I want to create this beautiful music, which is really what they do, but I wanted to get out of my blinders. It's amazing how you can get stuck in the way you see information because you do it over and over and over again. And so inviting other people to interpret the same information that I'm using forces me to have another look at how they're approaching information. I could so easily stick this information in a computer and get an exact output of what this sounds like. But I'm really interested in the sort of idiosyncratic qualities that come in when humans interpret this. So that's why I work with musicians and not computers. So I have to hurry up a little bit because I think I'm going to be running out of time. But I wanted to just share with you another score that I've been working on. This is The Perfect Storm. Some of you may know this storm system. the perfect storm was a storm that came through the New England area, or actually the North American area, in 1991. And it was actually a storm that consisted of two storms. It was a Tropical Depression 8, or also called the hurricane storm, which was a low-pressure system that was hovering over the New England area and made this really, really strange kind of turn and twist. And then there was Hurricane Grace, and it was the energy of the dying storm of Hurricane Grace that actually fed the energy to the Tropical Depression 8 and created this perfect storm. It was the kind of scenario that meteorologists dream about, and it actually played itself out. And so I wrote a score based on that storm system. And so you see the score below. It's divvied up into 3 different acts. But the reason I was interested in the storm is because people always talk about weather when they see my work, and they always tell me their weather stories, which is really interesting. But almost everyone has heard of the perfect storm. And the reason they have is not because they're weather freaks, it's because they engage in popular culture. And so one of the ways that the storm system has entered our dialogue is through not only a book by Sebastian Junger, The Perfect Storm, but also, of course, George Clooney and the movie The Perfect Storm. So everybody knows this. And what I'm fascinated here is what happens to information when it enters that sort of popular culture dialogue, when Hollywood starts coming into the mix. Does the information get changed? Does it become fictional? What happens to the information of a storm? And you'll see in a second what I'm talking about. So basically what The Perfect Storm, the book and the movie is about, is the sinking of the Andrea Gale, a Gloucester-based fishing vessel that was out on the Grand Banks fishing and came back too late to avoid the storm. And the dotted line is the path of the storm, and then that more solid line is the path of the Andrea Gale. And it's assumed that it sank sometime around October 28th in the middle of the night. But what I'm interested here is this little guy here, a little island called Sable Island. It's believed that it sank near Sable Island. Well, Sable Island has a very interesting history because Sable Island is known as the graveyard of the Atlantic. It's this very thin strip of, it's like 1 kilometer wide and 40 kilometers long, so it's very thin but long, and it's basically a sandbank. And when you look at this chart on the left here, all these little things that you can't see from back there are actually shipwrecks. So there have been tons and tons of shipwrecks. And when you think about it, it's the only piece of land nearby. You're in a storm, you're floundering around. Of course you're gonna aim for that piece of land. The problem are the currents around this piece of land. They are very, very treacherous, and a lot of these ships sank not because of the storm, but because of the currents. And when you look closer and you see some of these names, these are all the ships that have sunk near the Sable Island. They're all from the 18th, 17th century, 19th century. When you go back to weather data that far back, you don't get nice weather charts. It's not like Weather Underground nowadays, and you get this really great chart full of weather data. You don't have that. So how is weather preserved in the past? Well, it's preserved through songs. It's preserved through folklore. It's preserved through poems. And so in a weird way, these songs, these poems, become a kind of data. And what I've been struggling with is how do I deal with this information that is so embryoned in fiction, but is still information, it still conveys information about the storm system. And when I was doing my research, I came across Horace Beck, who wrote this wonderful book called The Folklore and the Sea. And he wrote the following: for folklore to survive and flourish, it requires a very special climate. It survives because in some ways it's functional. Environment plays a large part in its creation, shaping, and preserving. Few areas of the world are better suited in the preservation and creation of folklore than the sea. Because man is not indigenous to the sea, neither is folklore entirely indigenous. Rather, the majority of this material comes from the land and is adjusted to fit the aquatic climate. In brief, the folklore of the sea is the flotsam and jetsam of folklore from many lands, from many people, over many centuries, that has become immersed in the brine of the oceans and has become a product as different from the original as is the resin that is soaked in seawater and becomes amber. So these are then a series of pieces that I did, kind of struggling, I guess I should say, with this dichotomy of objective data coming from weather stations and then this sort of very fictional data that is historical data. So this is the score translated into a sculpture. So each of these masts is one of the acts of the score. Then I also did another version of the score, which is a wall piece that is taking the track of the score, track of the two storm systems, and looking at wind and humidity, wind and barometric pressure readings. And then another one that looks only at the wind readings of that particular night when the storm system sank. So these scores that I write really become the source for many, many sculptures. OK, I'm going to finish by talking about changing waters, because I think how much time do I? Ooh, OK, I'm going to race through this. So changing waters is a piece and large-scale installation. And again, it took me over a year to make. So data translation is not something that gets done very quickly. Changing Waters is an installation that I made where I was trying to understand the interaction between ocean system and weather systems, again, in the Gulf of Maine, our ocean waters in New England. And the Gulf of Maine is fascinating. It's an area that is very, very rich in marine diversity. And the reason it is so rich in marine diversity has to do with the geography of the Gulf of Maine. In this map, you see very dark areas, and then you see also very light areas. The dark areas are the deep basins of the ocean, and the light areas are the banks, the very shallow areas. And because you have a lot of shallow areas and a lot of deep areas, you have a lot of friction, a lot of tidal currents that create friction that bring up a lot of upwelling, and that brings a lot of nutrients up to the surface, and fish love it. And mixed with that geography, you also have the nutrient-rich waters of the Labrador Current that come from the north into the Gulf of Maine and kind of circulate it and then go out the South Channel. So it's very, very rich. And in that installation, what I wanted to have is I wanted to use all the buoys that are out there on the ocean and use them as a way of gathering information. But I also wanted that 12-year-old kid that uses toys, that uses this sort of idiosyncratic way of trying to kind of batch together an understanding. So it wasn't meant to be a three-dimensional oceanography textbook. I really wanted it to be very playful. And so I approached it through two ways. First, through the perspective of a bird. So this is basically the Gulf of Maine, a map of the Gulf of Maine. And it's 32 feet long. And when you get closer, you realize, oh, this all means something. There's hurricanes, there's geographic areas, there are tidal currents, there are buoys, there are weather stations. And then you notice that the Labrador Current and the Gulf Stream are both dragons. Well, what are these dragons about? These dragons are a reference to the New England sea serpent, because we actually also have our monster. And what's interesting, again, very much like what happened with the perfect storm, this is one of those legends that's been kind of kept up for hundreds and hundreds of years. And some serious and some not so serious, like Tony Sarg making this inflatable sea serpent that he put on Nantucket. But it stays alive, and it stays part of the history and the story of this region. And so that's why these things are dragons. So you go, you see more stuff. There's Jordan Basin, there's buoys, there's weather stations, there's rivers. And then you get closer, you stick your nose even further in, and you realize, wow, there's actually fish and cod and water currents and whales. And so you can actually read the whole marine diversity in the ecosystems from this. And of course, it looks like a crazy carnival ride, which is very much intended to be so. But I also wanted to bring the viewer into this installation from the perspective of a fish. And so I was thinking, OK, I'm going to use a kelp forest and a spinning toy as my model. And so I made these 13 feet long sculptures that look at specific aspects of the Gulf of Maine. And so so most of us would be about 2/3 of that height. And then, so this is one of the examples of it. It's a buoy that's located out in the Northeast Channel. So it's taking all this information from the buoy from 1 year's worth that it's collecting. But then you also have the Labrador Current circling through and coming out as the dragon. So I'm going to stop here. I have some other stuff, but I know I'm running out of time. So really, what I'm trying to do here is, or the reason I'm interested in this and why I kind of keep going back to the studio day after day after day, is because the basket and making this information tactile has been a window into making the science behind this more real. And as somebody who is so tactile, who you can tell me your name, I won't remember it, I have to actually physically write it down so I can remember it. It's been a window of opportunity to really dive into science that would have been completely closed off to me had I not found this way. And there's a lot of interest for this work as a kind of mediator between science and, let's say, the general public. And And I do a lot of this work. It's sort of more like translating or more didactic work, and I'm fine with that. But what I really want to see this work at, I really want to see us tinkering more physically with information. With every iPad that comes out, there should be a Lego box that goes with it, so that we don't forget that the hand, as much as the eye, is really important in understanding information. Thank you very much.